Right, this is Geometry and Construction, Semester 1 Review, Part 3, so Unit 3 here. So for 23 through 26, we're going to find the value of x. Okay. So here we're using trig or inverse trig to find, we're using the regular trig functions if we're finding a side, and we use the inverse trig functions if we're finding an angle. So our first step is to label our sides. So we're using the 40 degrees here. Okay, the x is the hypotenuse. That's the side across from the right angle. All right, and then 13 is next to the 40 degrees, so that's our adjacent. All right, and if we use our mnemonic SOHCAHTOA here, so SOHCAHTOA. Okay, we have adjacent and hypotenuse, so we have the a and the h, so that's going to be cosine. And we use regular cosine because we're solving for a side. So cosine of 40 equals the ratio of the adjacent side over the hypotenuse. So that's going to be 13 over x. All right, we're going to multiply both sides by x, right, because we want to get x out of the denominator. All right, and then we have x times cosine of 40 equals 13. All right, and then to get x by itself, we're simply going to divide both sides by the cosine of 40. All right, so that cancels there. All right, and we're left with x equals. Okay, and we plug into our calculator 13 divided by cosine of 40, and I get 16.97. So that's going to round up to 17.0. Okay. All right, the second one here, we circle the angle we're looking at first. I would label the hypotenuse next, so the 2300 is your hypotenuse. And then the x is across from the angle we're looking at, so that's your opposite side. Right, if we use SOHCAHTOA as our mnemonic. Okay, sine, right, is opposite over hypotenuse, so we have opposite and hypotenuse, so we're going to use sine. Right, so sine of our angle, sine of 32, is going to equal the ratio of the opposite side, which is x, over the hypotenuse, which is 2300. Right, and then to get x by itself, we can multiply both sides by 2300. Right, and so that's going to give us 2300 times sine of 32. So again, make sure you're in degrees, and we're going to do 2300 times the sine of 32. And that's going to give me 1218.8. So 1218.8 is going to equal x. All right, the next one here, we're solving for an angle. So we're going to have to use inverse trig functions. Our hypotenuse is across from the right angle, so that's our blank side. Across from our angle in question is going to be the opposite side, so 82 here is opposite. And then 59 is next to, so that's adjacent. So again, if we use our mnemonic, SOHCAHTOA. Okay, we have opposite and adjacent. That's going to be a tangent. And we're solving for an angle, so we're going to use inverse tangent. So inverse tangent, and then we plug into our ratio, the input to our ratio. The input into our function, the inverse tangent function, is our ratio of opposite over adjacent. So that's going to be 82 over 39. Or 82 over 59. Right, and that's going to equal our angle measure. So on my calculator, make sure I'm in degrees. I'm going to hit the inverse button. Okay, and then inverse tangent, and then the ratio is 82 divided by 59. And I get 54.3 degrees. is x. Okay. 26. We have a 45-degree angle here. Okay. Hypotenuse is the 45 across from the right angle here. Okay, and then x is going to be opposite. It's across from the angle in question. So again, SOHCAHTOA. We're using for all of these. Okay, so sine, opposite, and hypotenuse, we're going to use sine. And we're going to use regular sine because we're solving for a side. So the sine of 45 equals opposite over hypotenuse. So that's going to equal x over 45. Okay, and then we're simply going to multiply both sides by 45 to get x by itself. So those cancel. Right, and then we get 45 times the sine of 45. So if we put that in our calculator, make sure we're in degrees. And I got 31.8 for x. Okay. The angle of elevation, so of a ramp. Okay, so it's telling us our hypotenuse here is 36 feet long. Okay, and the rise is 2.5 feet. And they want us to find the angle of elevation. That's the angle going up. So this angle down here. Okay, so to find the measure of that angle, we're going to have to use the inverse trig function. So again, SOHCAHTOA is the mnemonic we want to use for all of these. Okay, the 36 they're telling us is the hypotenuse. Okay, and the 2.5, the rise there is going to be your opposite. So we have opposite and hypotenuse. That means we're using sine. And again, since we're solving for an angle this time, we're going to use inverse sine. So we're going to use the inverse sine function, and we're going to input the ratio of the opposite over the hypotenuse. So 2.5 over 36. And that's going to give us the value of our angle of elevation x. So if we go to our calculators, make sure you're in degrees. We're going to do inverse sine, and then input 2.5 divided by 36. And I got 3.98. So I'm going to put that that rounds up to 4.0. Okay, 4.0 degrees. All right, 28 here, find the length of the rafter. All right, well, again, we have a right triangle. Okay, we have an angle here. This is our right angle over here. So x is our hypotenuse. 16 is next to the angle in question, so that's going to be our adjacent. So once again, we can use SOHCAHTOA. Okay, we have adjacent and hypotenuse, so that's cosine. We're solving for a sine, so it's just regular cosine. So cosine of 24 degrees is going to equal the adjacent side over the hypotenuse. So that's going to be 16 over x. Right, we got to get x by itself, so we multiply both sides by x to get it out of the denominator. So that gives us x times cosine of 24 equals 16. And then we can divide both sides by cosine of 24. Right, so they cancel out on this side and we're left with x. On the right side, we got to go to the calculator. 16 divided by cosine of 24. So 16 divided by, make sure you're in degrees. Cosine 24. And I got 17.5 feet. All right, 29 here. The plot of land shown below has the given measurements. What is the measure of angle x? So we're trying to find the measure of an angle, so we're going to use our SOHCAHTOA. Okay, so all right, so we're looking for this angle here. The hypotenuse is the blank side. So across from the angle x here is going to be your opposite. Okay, and next to is going to be your adjacent. All right, so we have opposite and adjacent, that's tangent, and we're solving for an angle, so we're going to use inverse tangent. And then we're going to input the ratio of opposite over adjacent. So 315 feet over 276 feet. That's going to give us x. All right, so we got to go to the calculator. Inverse, make sure you're in degrees. Inverse tangent, 315 divided by 276. And we get 48.8 degrees. So 48.8 degrees. All right, 30 here. Find the height of a tree if the angle of elevation is 20 degrees through a piece of surveying equipment, and you are standing 120 feet from the base of the tree. The height of the surveying equipment is 5 feet. All right, so here's your tree. Okay, you're standing 120 feet away. Okay. All right, and we're looking for the height of the tree. Okay, but we're looking through a surveying equipment, so that's 5 feet off the ground. Right, so we're really looking at a triangle that looks like this. That last line was not good. Right, this is really the triangle we're looking at. Right, we know it's 120 feet long. Right, we're looking for the height of the tree, and we know the angle of elevation is 20 degrees. Right, so we have this angle here. X would be your opposite. Okay, and then 120 is your adjacent. Okay, so opposite and adjacent, that means we're going to use tangent, right? So SOHCAHTOA. So we're going to use tangent, opposite and adjacent. So we're solving for a side, so it's regular tangent. So tangent, input the angle, 20, is going to equal the ratio of opposite over adjacent. So x over 120. And then to solve this, you're simply multiplying both sides by 120. Okay, and we got to use our calculator then. 120 times the tangent of 20. And that gives us 43.7 feet. 43.7. Right, so our tree here is going to be 43.7 feet tall. Right, the next one here. Nope, that's actually not the height of the tree. We then need to add 5 to that as well, right? So that was x here. Right, but the height of the tree is x plus this little extra piece down here, which is 5. So we then need to add 5 here, right, for that extra height for the surveying equipment, because the x is just the height of the triangle. But the triangle is 5 feet off the ground because it's at the top of the surveying equipment. Right, so that's going to give us 48.7 feet. Okay. So the height of the tree is 48.7 feet. This height of our triangle plus 5. Right, 31, the ramp has an angle of elevation of 2 degrees. The ramp is 1,050 feet long, and they have that as the hypotenuse in here. How much elevation does the ramp gain? So how far up does it go? So we have an angle measure and then one side, and we're looking for a second side. So we're going to use SOHCAHTOA. Okay, hypotenuse in this is 1,050 feet. Okay, we're looking at the 2 degrees, so x is across from that, so x is opposite. So opposite and hypotenuse, we're going to use sine. So sine of 2 degrees is going to equal opposite over hypotenuse, x over 1,050. Right, to solve this, we want to multiply both sides by 1,050. Right, and that's going to give us x equals 1,050 times the sine of 2 degrees. So 1,050 times the sine, make sure you're in degrees. Okay, and I got 36.6. Right, and that's going to be feet. So the ramp gained here is going to be 36.6 feet. All right, last one here. Okay, find the height of the support beam. So in this one, we have 2 sides already, and we're looking for a third side. So that's going to be Pythagorean Theorem. Right, this is a right triangle. We have 2 sides. We're looking for the third. It's going to be a squared plus b squared equals c squared. Right, your hypotenuse is clearly the 18. So that's going to be your c. And then your 2 legs are going to be the 16 and the x, the ones that are adjacent. Okay, so we can have 16 squared plus x squared equals 18 squared. Right, so that's 256 plus x squared, and then I don't know, 18 times 18, 324. Right, subtract 256 from both sides, and you're left with x squared equals, what is that, 44 plus 24, 68, right? Okay, and then you got to take the square root of both sides to get rid of the square. So we take square root of 68 here. That's going to be 8.2. So x is going to be 8.2 feet. Okay, and that's it for the geometry in construction semester 1 review.